All right, folks, you're gonna get some pizza, get settled down. We're gonna get started in about 60-ish seconds. Oh, you switched to me. I see. No, program two. Program two here.
Oh, yeah. Okay.
Everything's.
Yeah, I was just going to cut to cam 2.
You can switch to cam two. Well, yeah.
Yeah, I see.
How do you say your last name? Sitnikov? Perfect. All right, folks. Welcome to CHADEV. Thanks for coming out today. We've got Tim Sitnikov with text-only lean software development workflow, which I'm really excited about. I know Tim does some embedded development, and I've been playing around in that space, Internet of Things, that sort of thing. So I'm excited to see his tool chain and etc. Couple of announcements, or at least one. Tonight is actually the Edney Innovation Center's open house. So it's really kind of the, hey, we're actually here and we're open and here's everything that's happening. So at 5:30, the whole building will be opened up. There'll be companies on different floors kind of showing off what they're doing, who they are. There'll be food and drinks, etc. Should be a lot of fun. We'd love for everybody to come out. So hopefully we'll see you there. Any other meetup announcements? I know we had Hack Night last night, so that will happen in 2 weeks from last night. You should show up for that. It's really fun. Sure, yeah, absolutely. This is Agile Chattanooga.
Yeah, hello all. We started Agile Chattanooga a couple of weeks ago. It's being hosted at on the last Wednesday of the month over at BDC. We're on meetup.com, so check it out. I'd like to see you guys come along as well. So.
Thank you. All right. Without further ado, I guess we'll hear from Tim. Thank you.
Hey, hello everybody. All right, so I'm going to talk about, well, first of all, just to say a couple of words about myself. I came to Chattanooga about 3 years ago to work on embedded system / overall system that we're doing. And essentially, what we're doing at Mueller is we have a complete stack where we take pressure measurements, okay, like a water pressure measurements, and we take that information from almost anywhere, away from a building, away from infrastructure, and we gather the data over time, and then every once in a while we wake up our modem on our device. It's actually a cellular modem, and we send that data to the cloud. Okay, we process that data in the cloud, and then we present each customer their own data sets. Okay, so I'm responsible for the embedded development. I do pretty much the whole embedded development, and then I'm also responsible for the system architecture. Okay, Our team is very lean. We don't have a lot of people to work on this project. But as you can see, the project is very complex. Our project is based on Ruby on Rails. Sometimes, of course, when you deal with Ruby on Rails and data, Ruby is not really good at processing a lot of data. So what we do is we use some C++. We also use some Java. And when you're doing, web development, there's JavaScript, JS, there's SQL, and there's a bunch of configuration files. So from the cloud point of view, there's a ton of different mindsets, different ways of thinking, possibly different packages, IDEs to work in those programs. On the embedded side, we have a little embedded system that gets buried in the ground, and that system stays in the ground for 5, maybe 10 years, and you're not supposed to have to touch the system. It's supposed to just function autonomously for a long time and upload the data to you. Now, the whole thing runs on little 4 D-cell batteries. Of course, your cell phone, you have to recharge it every so often, but that thing you can't recharge. So anyway, the embedded system has to be written in a very efficient manner. We have to use a relatively small microcontroller so it doesn't consume a lot of power. So to develop the embedded system, we use C++. And the tools that we need for embedded development is C++, of course, and we use makefiles, and we use Markdown to kind of make notes for each other. And then when I do system specifications, being a system architect, I usually work in Markdowns. Now, to display information and to show, to express very well how the system is laid out, how the data is put together, it's really good to use diagrams, okay? So how do you deal with that, I'm talking about pure text workflow. How do you deal with the diagrams, okay? So we deal with that as well. And on the top of that, we develop locally, okay? Then we pop into SSH and we develop remotely. We work over serial connections and we work with Git. Furthermore, our team is spread all over the world, okay? We have some people who are working here in US locally, and we have some people who are in other countries that are adding to our code, okay? How do we communicate? How do we make our communications efficient, okay? So there's workflow challenges that we as people face, okay? So when I'm trying to develop something, I'm trying to be lean. I'm trying to develop as quickly as possible. And throughout my career, I've noticed a couple things. When you use a lot of different packages to do your development, it's actually a little bit of a barrier. Like, for example, if you're in an IDE for a long time, let's say a day and a half, 2 days, you're trying to work something out, and then you have to pop into Microsoft Word, it's kind of like a mental block, okay? It's a different mindset, different way of thinking. It's not very comfortable to go from one to another. So sometimes it takes time for us people to go from one mindset to another. That could take 1 minute, that could take half an hour, depending on how drastic the change is. And then sometimes you have taxing processes, okay? What I mean by taxing, like when somebody takes a tax, right, from you. So part of your mental capability is dedicated to your core. And when I say the core, I mean, what does your code look like? What is your system supposed to do? So in order to contribute to your code, you need to focus on your code. But when your idea is complex and you have to think about, well, how do I get this done? Well, how do I get that done? It also becomes kind of a difficult thing. Now, even worse than that, sometimes you can have your IDE could have a bug, okay? And you have to work around that bug. Sometimes IDE gets updated, and usually, like, Eclipse is pretty annoying sometimes because when they push an update, they always ask you, do you want to update? Do you want to update? Okay, fine, I'll do update today. You do an update and something doesn't work, okay? So the IDEs could be complex, and then the IDEs also sometimes they try to abstract the complexity. But when they abstract the complexity away from you, they also abstract the capability sometimes away from you. So I'm just going to dive a little bit deeper into into the barriers. Okay, so when you deal with the barriers, what happens is, as you're working, okay, your mindset, as you're working on your code, let's say, right, your mindset kind of gets accustomed to your variables, okay? Your mindset gets kind of accustomed how you enter the text, how you set the text, how you run your, let's say, you make files, or how you make your system run. And then all of a sudden you go from that idea to, let's say, you go to Microsoft Excel because you need to work on your specifications, right? And you have them annotated. And when you do that, you know, we as people, I'd like to show a diagram where everybody just smoothly jumps over that barrier and keeps going, right? But when you jump over, it takes your mental energy, okay? Sometimes when you jump over, you fall. What I mean by that is like, okay, gosh, I gotta do this. I don't feel like doing it. I don't feel like changing to this, so I'm just gonna go for a coffee break, okay? You go for a coffee break, you get stuck talking to somebody else. So that could impede the flow, okay? And then, of course, going from, like, let's say, an IDE to Microsoft Excel, Microsoft Word, or even, you know, if you want to go to pop into a terminal and to do something in a terminal, you have to use the mouse, go back and forth, left and right. It becomes pretty uncomfortable. And then, you know, the task and process, right? I kind of have a diagram on the right. If you have to focus a lot on how to get things done with your IDE, right? You can only push so much. And that really cuts away from your productivity. But then, of course, the question is, how do you make it so that you don't have to focus very much on on your process, but focus on the code, really something that produces something meaningful for you. So, what is an awesome flow? I mean, I'm saying awesome flow, and I'm really proud of the way we're working now. It took a long time to realize it. In the beginning, there was this craze, you know. Well, at first, everybody did everything command line way. And then Borland came up with this package where they dedicated about this much space for the code, and there's a bunch of buttons, you know. You can do pretty much everything via those buttons. People kind of liked it. I went along with that craze. I liked it too. I used IDEs. And I thought that whatever is happening underneath IDE is too complex for me. I can't deal with that stuff. Another thing that was kind of interesting, you know, the first time I opened up a man file in Linux, I opened it up, I looked at it for 5 seconds, I'm like, this is not for me. I'm not smart enough to read this stuff, you know? So I closed it. And from that point on, I didn't look at the man file for a long time, till I was forced to. And then one day, I was forced to look at that man file. Okay, I read one man file very carefully. It took me a long time. I read another man file very carefully. It took me less time. And then after a while, I learned, okay, that all this complexity is not really necessary for us. So what I found is that to achieve good, smooth flow, like that flow around that Mercedes, right? To achieve that good, non-turbulent flow, what you want to do is you want to use as few packages as possible. You want to use simple to use packages. You also want to choose powerful packages that can handle as many tasks as possible. And I'm saying here too, avoid relying on IDEs. They have their own quirks, okay? You work on Java IDE, you work on C++ IDE, different mindset, you have to switch. That's like hitting a barrier, okay? And then when you work on something, try to be consistent and not make any drastic changes for like 5 to 10 years, okay? And I'll talk more about that. And then also, command line tools are awesome, okay? I've learned to work with command line tools to read those man files, and I feel that that makes me more efficient in really understanding at a fundamental level what's going on within the system. So one thing that I do is I have what I call a minimum tool set, and it's actually terminal, it's Git, it's Vim. I actually use NeoVim, NVim, and I use Tmux, okay? That's my tool set. And then within that tool set, there's different ways of doing things. The bulk of my methodology, how I do things, kind of stays very consistent over a long period of time. But what I do is I kind of deprecate old ways that I find to be cumbersome, not so good, I kind of let go of them, and I try to integrate new things. I go to YouTube sometimes, I learn how people do stuff, and so sometimes you kind of get used to a way of doing it. It may not be efficient, but they feel dear to you because that's how you've always done it. Going to a new way is kind of, it makes waves within, within your workflow. So what I try to do is I try to let go of very few things and always try to learn something new that helps me to be more effective. So, and here's my problem that I've got with IDEs, okay? So when you use IDEs and you don't really take time to understand the fundamentals of your system, let's say you work with Java, okay? So you have Java virtual machine that you've got, okay? And that's a layer of complexity. Then you got the Eclipse, okay? And that's another layer of complexity. And then you got plugins. Well, when somebody developed that Eclipse, they thought in their mind, okay, well, this is how the people should work. They put together workflow how they think people should work, okay? And they hand it to you and they say, here's how you should work. And so that's what you got to deal with, okay? So that's for Java. Now, if you go to like a Ruby IDE, Ruby people thought, well, you should work like this, okay? So with abstraction layers, everybody thinks that you should do things their own way. And you have to go from, let's say Eclipse, you go to JetBeans or other packages. I think there's even Python packages available as an IDE packages. But what happens is you kind of have to switch your gears. You have to learn new packages. You have to deal with bugs and errors of those packages because they will happen in those abstraction layers. So what I'm going to do now is I'm going to pop into a terminal, okay? Let me see how to get this out. Okay, and actually, if you look at my, I don't use any kind of fancy Windows user interface. What I use a very simple Windows Manager. It's called i3 Windows Manager because when you have to deal with a lot of buttons, they just take away from your capabilities, I think. So anyway, I'm going to pop into a terminal here. I'm going to push this out. Okay. Okay, so our workflow starts, of course, everybody workflow starts with some kind of specification, right? We write some kind of specifications. So let's say this is my specification file, okay? Okay, I popped into Vim here, okay? Let's say we're going to do something simple, okay? And this is a specification for a PDU that consists of 5 bytes. The first byte should be length of the payload. The following 4 bytes shall be unit time step of some event, okay? Whatever it is, okay? It's not important. What's important is here we have a specification, okay? And then I say I'm going to also write a specification that says, okay, provide a set method, and I provide what this set method should look like, okay? So when I do something like this, I'm going to turn this here a little bit. I'm going to save it, okay? And I actually already started a Git. So what I'm going to do is I'm going to say Git status, what's in here. And the first thing I'm going to do is I'm going to add that specification and put it to GitHub, okay? Okay. So then what I'm going to do is I'm going to take a little bit different approach here. Okay, there's two terminals. I wish I had it mirrored, but I didn't have it mirrored, so it's going to be a little bit difficult for me to work with it. Okay, so then what we do is we create a Git repository. I'm just going to call it demo, okay? And then Git actually goes ahead and it tells me, GitHub that is, that in order for me to add this is what I have to do. And I go back into my terminal here. Okay, I'm going to do git push. Okay, so all of a sudden, you know, when we come into here, we can see a commit, right? And a person who is responsible for writing the code can come here and look at this particular commit, okay? Of course, it doesn't look right. Wow, okay. Let's turn the lights down a little bit because I have a hard time seeing my mouse. Okay, that's better. Thank you. Okay. So we just push the specification over, okay? And then a person who is responsible for working now has the specification, okay? Okay, but the problem with the specifications is that this specification gives you data layout. But when you have a data layout, the problem with a data layout is that you need to have some kind of a diagram because sometimes you can communicate things, but I'm saying here PDU should consist of 5 bytes. But you don't really see those 5 bytes, right? I mean, when you read about 5 bytes, you can kind of make sense out of it if you speak good English. But what if you send this overseas, okay? If you send this overseas, I'm going to very quickly here put together a little diagram, and this is going to be a pure ASCII diagram, okay? Okay. Okay, I'm going to go, this is going to be file header or PDU header, okay? I'm going to drop one of this. Okay. And then all of a sudden, I came up with a diagram, but then, of course, I would have to, okay, this is my t byte 1, time byte 1. And then here what I can do, I can annotate and say, okay, pH is your, and then T1 to T, actually should be 4. 4 is, okay. okay, now that I did this, okay, you can see my pocket data much easier, and a person that's somewhere overseas can see this diagram. Now, what you could have done is you could have used a program such as Dia, and you could have added this diagram in that program. But what you would have to do is you would have to go into a whole different package. You would have to generate the diagram. You would have to output, and then you would have to push that back into Git. Okay. Then what I do here is I'm gonna do GStatus. Okay. So right now, okay, what I'm doing is I'm using the same package, and in this package, I typed in the command GStatus, okay? And then this command allows me to add and subtract things in Git. So this particular Vim is very powerful. Vim allows me to do different things. And right here, I'm managing my Git files in Vim without even have to pop out into terminal, okay? So this is the modified file. Okay, I'm going to add it, okay? I'm going to commit, okay? I'm going to add, and I'm going to type update, okay? Once I quit, it updates it, and then I can do push, okay? Once I just pushed it, okay, somebody else who is out there somewhere writing my code has an update, okay? So I can go into here, and I can hit the spec, okay? And of course, one thing that I forgot to do as I was talking to you is I forgot to add something for Git to know that not to modify any of it. Okay, so this will show up in the next push, but essentially, well, let me just do it quickly. Okay, and I'm updating. Okay. So of course we pushed it up, and here you go. All of a sudden, right here, you have a diagram, okay? You can get very fancy with diagrams. You can put together different diagrams. And this works really well for us because what happens is if you add an actual JPEG, you can't diff this JPEG. So if you go into here, and if you go into the code, and then if you go into commits, right, and you look at this commit right here, this is the last commit, okay? This commit shows you a diff, okay? So whenever somebody comes into here, they can see, okay, well, in the last commit, I just added those little quotation marks here so that, you know, we can see it a little bit better. And usually, our developers, our web developers, you know how we sometimes, when we go in the office, we look at the news, you know, check out our email, get a cup of coffee. Our web developers actually go to their Git and they'll look at this site. They look at the diffs, things that we have changed, okay? So this is actually very powerful. Now, sometimes you think, well, drawing those diagrams in ASCII is not very pleasant, it's very difficult. But when you kind of get used to it, it becomes pretty easy and it becomes, you become very quick at it. So what I'm going to do is I'm going to show you some diagrams that we actually have at my work, that we do at my work. Okay, I'm going to go here into web application, specification, and this is system interface that we do, okay? This is actually a system interface that I worked out, okay? Here's a simple diagram that I put together, pure text, okay? The people out there are able to see this text, if I make any change inside of any of these boxes, people can see that I made that change, okay? So then, of course, you sequence of events diagram right here. I mean, you can use a fancy package. But when you go into a fancy package, when you generate that diagram, it's, you have to change your mindset, and that's a barrier, okay? So you think, okay, well, so what do I do? Do I put together a diagram that kind of makes it somewhat more clear for somebody who doesn't know English, or do I just write it out in text, okay? I'm going to argue that if you have to pop into different program, different mindset, you may not add a diagram in there that will make it easier to see for everybody, okay? But if you can just do it in text like this and you kind of learn how to do it, guess what? You'll probably just put a diagram together in Vim or whatever your favorite word processor or word or text editor is, okay? Now, in this case, this is in my opinion, this is a beautiful table. So this table was actually put together in text as well. It's pure text, but Git displays it in a very nice manner. So this is kind of ASCII art as well. Here I have a little sequence diagram, okay, and this says, okay, here are my events, okay. This is very easy to say, sequence of events. Also, what you can do is, if you don't want to format some text and you just want to say it the way it is, for example, like here I'm describing what a CBOR array is. I provide pure text. I add those quotes on top and the bottom. If I make any changes to this, people are going to be able to see the changes that I had made, okay. So I'm going to go a little bit farther down. We have a lot of sequence diagrams. Right here, this is a file. This is our data file that we actually send over the web. And so this file had to be, is used by me. I use this diagram when I do the embedded development, and also the people who are doing the web development are also using this diagram. So I'm saying, okay, well, here's a header, sample 1, sample 0, sample 1, and just pure text. Very easy to see, okay? Then if you go down here, of course, I go ahead and kind of give a little bit more information about what is a BF, and I kind of specify, okay, well, this is a bit field, and it's a bit field. The first bit is whether the bit is transient file or a sampling file, okay, and I give a little bit more specification there. Then what I can do sometimes is sometimes I take, I annotate each individual bit, because you know, when you work with embedded development, you do that. And so, again, pure text file right here. This right here is my time in sequence, okay? I'm saying, okay, well, time is moving in this direction. The space between the header timestamp and the sample 0 is, for example, is 5 seconds, and I actually talk about this. And then you can see, okay, well, this is my sample 1, and this is my sample 0, this is my sample 1, and I talk about the values. And so, of course, you know, you can write it all with words, but you know what? You know, with a text editor, adding this does not take much time at all, okay? So then we go down here, and here I kind of talk about the actions and the way the time flows. And I mean, this looks kind of confusing at first, but when you think about and you read a little bit around it, it talks about what is an overlap, okay? What is, when you overlap, like right here, okay? What does it mean for two events to be duplicate, those kind of things. And then here, this is another data unit right here. And of course, whenever I say, okay, there's more data to come, I do something like this in the back, indicating that there could be as much data as you want, okay? And then, you know, sometimes what I do is I get as creative as putting together something like this, okay? When we log events within our microcontroller, you know, how do we handle those events? Well, this is how I start. This is my packet data unit when you start, okay? And then it gets translated in this data unit, okay? And I go ahead kind of clearly try to annotate it as clearly as possible. I mean, it looks complex, looks like it will take a long time to do it, but you know what? After a while, as you work on it, it doesn't take that much time, okay? And so, I'm going to go back here, okay? And I'm going to take this out. Okay, so let's say if I'm a developer, right? I go ahead and I go into here and I implement this class, okay? When I implement this class, I kind of do the same thing, okay? So I'm gonna go ahead and I'm gonna get status to kind of see status, what happened to me. Let's say before I was a system architect, now I'm actually doing the coding, okay? And I'm gonna take this PDU payload and I'm gonna add it, okay? I just highlight it and I click on the minus, that's one of the packages. I'm gonna go G commit. I'm gonna say, okay, I just implemented the code, okay? And I just pushed it, okay? So, but let's say somebody says, well, you know what? The problem is with this code, you know, we would like to add another byte to this data unit. Because of course, you know, you start with something small, you add more information, you add more data. So then what you do is, of course, you kind of would have to go into a web browser and you go into Git and you have to deal with it. And what I try to do is I try to stay in Vim and kind of get everything done in Vim because I'm really used to the way I edit the code in Vim. So I'm going to go G. Okay, so here's what I just did, okay? The repository that's out there on a Git has its own issues list. I typed in a command that pulls up, that creates a new issue for me, okay? And let's say the title of that issue, I'm gonna change it some, and it talks about who is it for, and let's say it's for me. And I say, change the code, okay? So when I write this issue, I just wrote this issue. Okay. Of course, I have to go back. I go into here. Go back to the other issues demo file. Okay. And now here, look at this. I come into here. There's a new issue right there that we just typed in. Okay. So having said this, okay, I just showed you the process that we go through, and essentially everything that we've done here is in one text editor, okay? Everything that we've worked with is within one text editor. So actually I'm gonna go show you one more thing, and then I'm gonna go here, okay, test. Okay, this, I opened the binary file by accident. So this is, let's say, a test file, okay, for the code that we just added, okay. Hold this open, and I'm gonna hit Control BB, okay. When I hit Control BB, what it does is it runs the make file and outputs a result, okay? On the bottom, I did a very simple test. I passed this test, okay? And then if I go into, I open up the make file. And this is where all of the magic occurs, of course, right? In this make file, when you use an IDE, you don't have to write make files like this, okay? But at the end of the day, in order for you to be effective with IDE, you need to understand what your compiler does. For example, if you look at line 47 up here, you have CXX flags, right? You have -G, that's to allow me to debug. When you use an IDE, somewhere, somehow, you have to find to turn on that flag. I mean, you know, one IDE does it one way, another IDE does it a different way. But if you know what -D means, you can just pop into here, you can add it very quickly to your make file. Make files, sometimes they look intimidating, but you know, once you get used to it, once you understand how it works, it's not too bad. Most of this stuff, of course, I copied it from Google Test. They provided a simple make file, and what I had to add myself is just this. This is what I changed, okay? So once you learn how to use make files, there's of course CMake as well. CMake is specifically for C family of compilers. I don't use CMake. The reason I don't use it is because you can't use it with everything, okay? I like to learn things that are applicable to everything. So when I use Java, okay, when I code in Java, I use make files, okay? I add class path to my system. Of course, I work with that. I add packages to my Vim that allows me to have code completion, that shows me if there's bugs or not, that kind of gives it this IDE feel. But I don't have to use a different package, okay? I don't have to use Eclipse or whatever other packages there are. And so this is basically our workflow. This is how we work. This is how I work. And then, of course, sometimes I do have to pop into Eclipse and to do some stuff because we're using a microcontroller that is proprietary. We use a microcontroller whose core is proprietary to Texas Instruments, and so you can't get away from Eclipse. But I don't like it, okay? The other interesting thing that happens is this. Eclipse is made to work with a microcontroller. Unfortunately, I don't work with just microcontroller. What I have to do is I have to look at the log files when my microcontroller communicates with the web, okay? So what I do is I pop into Tmux, I open up another Tmux terminal, and Tmux shows up on the right. So let me just do this quickly here. This is why I don't like mice, because, okay. So I'm going to hit Control B and then %. Oh, I didn't start a session. We'll go Tmux. Okay. I'm going to go NeoVim, Control B, and then %. What this does is opens up another session on the right. Okay. I'll just type ST, which does the whole SSH thing and connects me to a server. This server is in Atlanta, okay? And I'm gonna have to do this. Okay. So right here, what you're doing is you're viewing the log. On the right, you're viewing our actual log of events that are happening on our server, okay? And of course, this is a custom log right here. But if I needed to go to the left to work with my Vim, all I have to do is I have to hit Control H, which is essentially Vim directional key, okay? And here I can go into here and I can just say, okay, PDU H packet data, or, okay, well, PDU okay, so how did this work? Okay, I'm hitting keys because I'm trying to look over to the left. Okay, so if I'm coding, let's say right here, if I'm making some changes here, all I have to do is I don't even have to touch the mouse. I hit Control L and I'm on the left. I hit Control H, I'm on the right. And it allows me to pop left and right without going into different programs, into different terminals, into working with IDs. And I believe that this makes us more lean, more efficient in working with complex systems. So that's all I have to say here. Any questions?
So with all the graphs you were making, are you aware of any plugins for the terminal that might make it easier to create those diagrams that you showed us? Or do you do this by hand typically?
Well, there's a couple of things that you can do with Vim is you can have sub-blocks in Vim, and you can just use like auto-snips, okay? So you just type few keys and you type in Control-E, okay? And when you do that, it shows a diagram and you could add some intelligence to it so that you can edit it. So you can do it yourself. I don't find the need for it because every time I do something different.
Anybody else? I'm pretty impressed with your workflow. That's pretty cool stuff. Got a lot to learn from you on embedded stuff and staying in the terminal, because a lot of these embedded platforms, they have, like you said, Eclipse. They have their. I think in the interest of time, it's people need to get back to work, but we'll close up their own, compilers and all that. So working around that with the open source workflow is pretty awesome. Thanks to our sponsors, Colab, Enterprise Center, LPG, Carbon 5, and UTC for pizza today. And hopefully we'll see y'all next week. Thanks so much, Tim.